Hello viewers, welcome to Special Site. In this today's tutorial, I am going to show you how you can calculate area and percentage of a particular land use land cover class. Generally, when we do land use land cover classification, we get number of classes, and for the analysis, we tend to know how much area does a particular class occupies. And today in this tutorial, I'm going to show you how you can get those information in QGIS. So first, you need to load your land use land cover data. Uh, this land use land cover data I downloaded from ISRI website, and I have loaded it here. Now I'll be showing you from sketch here what you can do. Simply go to your data where you have got that data. Simply click and simply drag and just drag it here, and once you do that, you are going to see something like this. When you are done with this, now you can see some here, it's saying band and this 0 1 2 and something like that, and this black regions means there is no data. So what you can do is here simply just left click this classify. Once you do that, those black regions have gone, and now you only have in this lesson you can see only those values having data. So these are actually these values what you are seeing, this 1 2 5 7 8 11, these are the land use land cover classes. This and these are the DN values that will be in your data. And so the first thing that you need to do here is to calculate the area and percentage occupied by this each classes. This blue means water, this green, dark green means forest, and so on. Those are the classes name that you will know if you have done the classification or you have downloaded the data from somewhere. So the first step to do in this process is you need to convert this raster data into vector. So for that, you need to vectorize it. So for that, simply go to this raster, simply left click this raster, then go to conversion, simply conversion, and this polygonize raster to vector. We want to convert this raster to vector, so we are going into this option. Simply left click this, and once you do that, you will see this kind of interface, and there are two tabs, parameters and log. In this parameters, simply in input layer, just by default you will see this. If you have multiple layers, just choose that land use land cover class, which analysis you want to do. And band number, this is all by default, and this is name of the field to create, DN. It's saying DN, this has come by default. DN means actually the in those in raster there are pixels, and it refers to those pixel values. DN means later when it will be vectorized, you will see this 1 2 and these numbers, and other you don't need to do anything else. And the final thing, you need to save it. Simply click these three dot icons, left click this, and simply go to save to file. And once you do that, what you can do is just go to your directory, and what you want to save it, you can simply give it a name. And save its type, SSP. You can choose other thing that you want to do analysis. I am going with SSP, and simply click save. Once you do save, simply click this run. Okay, your classification has been done. Simply close. Vectorization has been done. Okay, now we need to create a new field here. First, let's open its attribute table. Simply just right click here and just go to open attribute table. Now, as I mentioned earlier, you will see you are going to see the DN by default, and you are going to see these numbers. If you left click here, and it will become in ascending order. Now what we need to do is we need to make a field name. We need to create a new field here. Suppose name, it could be type. And what we need to make sure is that this what this 2, 5, 7 and other things mean to say. So this 1 means water bodies, 2 means forest, and 5 means similar thing, and 7 means this urban and other classes are there. So now what I want to do is that I'm going to go to open attribute table, open raster calculator. I'm going there, and I will be giving a kind of code, and that says if there is 1, then go to water, if there is 2, go to forest, and similar thing. I'll be showing I will showing to you what I mean to say. Simply just left click this toggle editing mode. Once you are done with that, just go to this open field calculator, just left click here, and now you need to create a new field. Just keep the name of this output field name, just give it a name. Okay, now output field type, as I mentioned earlier, that means I want it as string, so I need to change this. Simply left click there, and text, go with this text. Output field in length, let it be 16. Okay, now the most important part is this one. What is the expression that you are going to hit here? As I did this analysis earlier, I'm simply going to this copy. I'll be explaining to this what you can do here. Earlier I had simply pressed Ctrl C, and simply I have pressed here Ctrl V. Okay, I'll be explaining to you what does this code means. So okay, so this is like a code, simple code. This is the case when dn equal to 1. You can see here dn is the field name, and when this dn value name is 1, what you do is then to string, means that the new field that we will create type. In that type, that corresponding this row field value will be water bodies. Similarly, when the dn value will be 2, the corresponding that row value of this type field will be forest, and similarly the things will go on. If this dn value is not given anything, at last you will see else 0, that means null value we are going to see, and at last int. I think you are understanding what I mean to say. This thing is quite simple. Okay, now if you are done with this, now you can simply press this OK. Okay, here we go. Now you can notice here 5 agriculture. Previously we had given the same. 5 means agriculture. Okay, 1 means water bodies. Okay, all the things are pretty clear. You can also check if you are not code has not worked accordingly, but you need to make sure that first what this 7, 8, 11 means, whether this 11 means sandy area or 7 means urban, or what does it means. You need to be clear about this thing. If you have downloaded this data from the website, in metadata you can see this information. If you have done your own classification using supervised or unsupervised, then you will know that thing. You also may be confused with one thing, that what this 555 this all thing mean. There are a lot of these values. This actually these are the small polygon lines. This all, as we have vectorized our raster data, our agriculture line has come into small polygon size, and this all mean those smaller polygon. Okay, now at first okay, we are done with this. Now we are going to calculate the area. I want to know this. Okay, just if you click here, you will get something highlighted here. Here it's being highlighted. Okay, once you do that, here it's a small portion and it may not be noticeable. Now what I want to learn is that how much this portion occupies. What is the area of this portion, this small agriculture feature? first, once you do that, once you calculate the area for all this respective, how much features we got here, this 420 features. Once you do that, 421 features. Once you do that, later you can aggregate those all those values, and you can calculate the whole area and percentage of a particular class. So for that, what you do is you again need to create a new field. Simply again you go here, just go to this open field calculator. Now output field name, output field type, what type, since the area can come in decimal, so I'm going with this decimal, this real one. Precision 2 is enough for me. And the thing to be noted here is, this is the important thing, output field name 10. 10 is quite a big number. Okay, it does not matter much. Simply you go to this geometry, just click this this arrow kind of icon, simply left click there, just double click this dollar area. Okay, once you are done with that, in preview option also you can see how much area this occupies. Make sure this is in meter square. Okay, once you are done with this, now what you can do is simply press, and once you do that, you are going to see, now you will get to see this output. You are seeing the output in this meter square of this particular feature. I would like to tell you one thing. Sometimes you may not see this output. You may see this this particular feature, only one feature, this area, and the rest of the other area may be null or blank. In that case, such case, what you need to do is that you again need to load the layer here. Remove that layer and again keep it there, and you are going to see that. Okay, now we are done with this. Okay, now we are done with this. Now what we are going to do is, here you can see here, this is sharp. In this sharp, there is a small all features are here, and individual area is given here. Now what we want to do is, we want to combine all this individual area. I want to see that what is the total area of the sharp. Likewise, in this water bodies also we want to combine, and what is the total area of this water bodies. Similar case to urban and other things. So for that we are going to use another tool. Just don't forget to this save it here. Okay, once you save it, I also going to remove this. I'll be removing this here. Once you save it, you just need to go to this you go to your processing toolbox panel, and what you search is, you need to search for statistics by categories. You need to search here. Okay, in my case, you can say I had used it previously, and under vector analysis, statistics by categories, you can see here, just double left click it. Once you do that, you will come here, and once you do that, you need to see here something. Now look at here, field to calculate statistics on. That means which is the field upon which you want to do the calculation. And this is area meter square. This is the field where I want the calculation. I want to add all those things. And another is fields with categories. Now fields with categories means which are the categories, means which are the classes. That means this means type. Okay, and once you are done with that, simply click this OK. And if it's done, now you need to save it somewhere. Simply click this three dot icons, go to save to file, and you just go here and save somewhere, and just save it here. Okay, in file you are going to save this in .dbf file. Simply save it here, just click this run. Okay, you don't care about this error because our we have done what we need to do. Okay, now if you will see here now, statistics, yeah, here, and other thing. So here is our statistics. Simply just click this and just drag it here. And once you do that, simply just press this open its attributable. Okay, now you are going to see here is a quite interesting tool, this statistics by categories. For those particular categories, now you can see here. Now you can see this. This count means in this sort there were smaller polygon features and how much were those their numbers 112. And similarly there are data for all other classes, and among those that particular class in SORP, and there were lots of features, and among those features what is their sum, what is the total sum, what is this this total, this sum means this what is the area, it means to say the area. In that option we choose area yum2, and that means it's working on the area. This all what you are seeing, this minimum, maximum, this median, and all these things are of that particular area. This sum means this all those polygon features of SORP has been added, and the total now the sum of area is this much. This is the sum of area for SORP. This is for forest, pier, and similar things, and this all are in meter square. So in this way you can calculate the area for that particular class feature. Okay, now we have the area, but we don't have the percentage. Now how we can calculate the percentage? Here are other options, other field names also. What is the minimum value of that area within those features of SORP for this particular value I am saying? And likewise, what was the mean of those polygon features of having those of that area? Since each polygon features were having certain area, in that area, what is the mean? Yeah, then what is the median of that all area that the data had? For this is for I'm talking about the subcategory, and the same thing is applies to this forest, bear, and rest of the thing. So these are the things what it mean to say. But now I'm just focused on this sum because I need the total area for this sum and similar things. So I'm going to simply remove all the all unwanted things that I don't want here. Simply go to delete field and just now how to calculate that percentage. Percentage means how much percentage the soil occupies in that land use land cover classification. Likewise, what is the percentage of forest in that area? And for that you need to simply do something. For that simply you go to again you go to this open field calculator, but make sure you need to this click this toggle editing mode for all the operations that you want to do. Just simply left click this open field calculator, and once you're there just keep the output field name. Okay, and in that percent what you do is that whole number integer is saying like that, and what you need to do is that that is your choice. What in if you want to go to integer, whole integer, you can go here. You are not going to see some value in decimal, but I want in decimal, so I have gone to that value. Okay, now output field length it's 10, it's quite okay, it's now must important thing here is this expression, what you are going to do here. I have a code for this and I will be also sharing this with you. Simply copy that and simply paste it here. Now what I mean to say is this, this count means this one, this count, this field name, and this sum means actually, this sum means a function. And what I mean to say is that how this code works is simply we do the calculation that marks operate upon total marks into 100%. Likewise here also, count, what is the count of the sub? 112 upon total sum of this count, all this total into 100%. And in this way you are going to calculate how much percentage a particular class occupies. And once you are done with this thing, you can simply, what you can do is that simply press OK. Okay, now you are able to see the percentage that a particular class occupies. So now if you add all these values, you are going to see the 100% total. So viewers, don't forget to save this and also toggle this editing mode off. So this is how we actually in such land use land cover classification, or maybe in other you have done multi-criteria decision analysis, site analysis thing, and you need to find how much that particular theme of data occupies area and percentage. This is the way how you do calculate this percentage and area. So thank you viewers for watching this tutorial. We are going to see soon in upcoming videos. Thank you.